Okay, given that sine theta squared is the same as sine squared theta, solve the equation la 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 on the interval 0 to 360 degrees. Alright, sine squared theta is 0.5. We want sine by itself, so we have to get this square off of it. So when you square root both sides of this expression, you get sine theta. Now I'm about to make a mistake, see if you can catch it. The trouble is, technically there are two ways that sine theta could get to 0.5 when you square it. It could be 0.707 or it could be minus 0.707. So this should have a plus or minus on it. Right? Because after you take this value and square it, it's going to come out to 0.5 either way, but the original number could have been a positive or a negative. That means when we are figuring out what quadrant we're in, we could actually be in any of the four. We could be in these two quadrants, where sine is positive 0.707, or we could be in the bottom two quadrants, where sine is minus 0.707. To get our reference angle, go to the calculator, give it 0.707. Don't tell it about the negative, it'll do something silly with it if you do. And second sine, I get 44.99 degrees, which I'm going to call 45 degrees. So our reference angle is 45, and it could be in any of these four quadrants. Now, they didn't want reference angles, they actually want standard rotation angles, and so we have to work out all four of these. The first one is easy. This angle really is 45 degrees. In quadrant 1, reference and rotation angles are the same. In quadrant 2, this is like go around to 180, but then back up 45 degrees. We get 135. In quadrant 3, we go around to 180 and then carry on another 45 degrees, total of 225. And finally, we can go all the way around to there, which is like going to 360 and then backing up 45 degrees. That is 315. So, four different solutions, all valid. They're all places where if you take this sine, you get 0.707 or minus 0.707. When you square it, you end up with 0.5.